Okay, welcome back everyone. Today I wanted to go over systems of equations and a couple different ways to solve them. So for the first one, you see here we have three different functions, and what you can do is just start plugging in one into the other and see if you can solve for the different variables. So here we have z equals 2, so we can plug that into y equals x minus z. So y equals x minus 2, and then you can take that and plug that into the first equation with x. So you have x equals 3y and z is 2. So that's 3 times x minus 2 plus 2. So that gives you 3x minus 6 plus 2, which equals 3x minus 4 for x. And then you want to isolate x in this equation. So you can subtract 3x from the left side. So x minus 3x equals minus 4. So you have minus 2x equals minus 4. And x is going to equal plus 2. So then you can take x equals 2 and put that into the other equation with x for y. So you have y equals 2 minus z, which is 2. So y is just going to equal 0. And we already know that z equals 2. So we've solved for all our variables. And then you can take those variables and plug them into any of the equations and see if they work. We already did y is 2 minus 2, so let's try x. So we have 2 equals 3 times 0, which is 0, plus 2, so 2 equals 2, and that one works. For problem number 2, we're going to use the same method as number 1. So let's take the second equation and solve that for x. So x equals 3y minus 2, and then plug that into the first equation. So 4 times 3y minus 2 minus 1/3 y equals 12. Then distribute the 4, 12y minus 8 minus 1/3 y equals 12. We can add the 8 over. So 12y minus 1/3 y equals 20. I could fix these fractions. So 36 minus 1 divided by 3 times y equals 20. So 35y, and then 3 times 20 is 60. So we have y equals 60 over 35, which if you simplify is going to end up being 12 over 7. So now that we have a value for y, we can take that and plug that into the first equation to solve for x. So 4x minus 1/3 times 12 over 7 equals 12. So that's 4x minus 12 over 21 equals 12, which is 4x minus, if you simplify that, that's going to be 4 over 7 equals 12. Gives you 4x, and if you add 4 over 7 over, that gives you 4 plus 84 over 7. That's going to be 88 over 7. And then if you divide by 4, x is going to equal 22 over 7. Okay, for problem 3, there's another way you can solve these systems of equations. And the way to do that is you can actually add the equations. So you just write it like that, and then just add the like terms. So 12 minus 3 is 9, so it gives you 9x. And then that goes to 0. And 9 minus 6 is 3. So 9x equals 3. Solve for x. X is 3 over 9, which is just 1/3 when you simplify. And then you can take x equals 1/3 and plug that into the first equation. So minus 3 times 1/3 plus 9y equals minus 6. Minus 3 times 1/3 is just minus 1. plus 9y equals minus 6. Add the 1 over, 9y equals minus 5, and y is just going to be minus 5/9. Okay, for the last problem here, we still want to add the equations together, but we should look and see if we can get rid of one of the terms first. So, in order to do that, I think I'm going to multiply the first equation by 2. So that gives you 4x plus 2y equals 1. And then you have the other equation, 4x minus 2y equals 2. And then we can add those together, and you get 8x plus 0 equals 3. So we got rid of the y's. So 8x equals 3. Divide both sides by 8, and you get x equals 3/8. So we just got our first variable. And then we can plug that back into the first equation. So 2 times, my writing is off here, 2 times 3/8 plus y equals 1. So that's 6/8 plus y equals 1. 6/8 simplifies into, see, 3/4 plus y equals 1. Y is 1 minus 3/4. So that equals 4 minus 3 over 4. And y is going to be 1/4.